from live. Okay, so today what I'm going to do is, with my functions, we want to talk specifically about a thing called periodic functions. Okay? So a periodic function is something that's going to happen over and over and over again. So you're going to have the same pattern that will extend. Same pattern over and over again, okay? Well, when we get down to here, I'll give a better definition. I'll give you a picture, okay? So here we go. First of all, if we have, here's an example of a periodic function, okay? The tides are periodic because they go in and out, in and out, in and out, in and out. And then the height of the tide and it's pretty close. Height of the tide, high tide, low tide is pretty close. The same thing day after day after day. They do change some, but seasons, right? We go from summer to winter. So a periodic function would be the length of the day. It changes, right? But over year after year after year, when we get to the equinox, which we're almost there, it's going to be a 12-hour day, right? Year after year after year after year. That's a periodic function. Well, let's take a first look at this. So if we have a value in front, this is going to be what we call the amplitude. Or, in words, the amplitude is like how tall. I want to draw a picture for you. No, just the A. Great question. Now, I'm a lousy artist, but this is a periodic function. It's just going to keep going and going and going. It's periodic because the shape stays the same, right? And it keeps going all around, around, around. This would be a sine curve. We haven't got there yet, but we're going to talk about what a sine curve is. And its amplitude is how tall. So in this case, it's how tall. So the amplitude would be how tall this thing is. Maybe it's 2, maybe it's 3, I don't know. Okay? If you have f of a of x, and then that describes its period, or the width of a curve. And we're even going to talk about the frequency of a curve. Let me finish this example. Okay, so in my example, I have a frequency of 1, 2. Do you see my frequency? I've got 2 curves. I have 1, 2. That's my frequency because I see 2 of them, right? You guys okay with that? Frequency just means how many, okay? But then the width of the curve is of one curve. The width of the curve of one curve is there. That's the width of the curve, okay? And that's its period, okay? How wide is one curve? So in music, or in sound, they talk about frequency, right? So if I have a really low frequency, it's a long wave. A really high frequency, it's a really short wave, okay? So all of this actually applies quite a bit to music and electronics, okay? So what is a periodic function? Well, it is a function that repeats over an infinite interval. And the big thing for me is this. It must have the same max and min. Okay, same max and min. So I'm going to scoot this back down. And again, I'm a lousy artist, but I'll let you write this down. I'll show you, okay? So periodic function that repeats over an infinite interval, okay? It's going to have the same max and min. That's important because if I take a look at this, the height here is the same height here, same height here. The minimum never changes also, correct? You guys see that? So I like, the best example is really, for us, really has to do with the seasons, right? We know that every single equinox, it's always a 12-hour day, right? And in the wintertime around here, daylight might be 8 hours, okay? It changes and then for us, summertime, you get the solstice, it might be 18 hours, right? Long. Well, I don't know if it's quite 8. Well, it might be 18 hours. But those never change year after year after year. From the dinosaurs until now, right? It's always been that way. Now, the period is going to be the length of one curve, okay? The period is the length of one curve. And I also want you to put down frequency. The frequency is the number of curves, okay? So the period is the length of a curve. The frequency is the number of the curve, okay? And the amplitude is just the height. So the amplitude is the height of the curve. We got to be careful on that one. I'll show you why. As soon as you write that down, I'll show you we got a little careful on that, okay? So the height of the curve is from, say, sea level, okay? The height of the curve is there, not the full thing. And I think the easiest way to do it is this way. I don't know how, if you guys have ever been out at sea in a boat. I mean, really, if you've ever been at sea in a boat, there's a point where you're at sea level in the boat, and then you rise up, and then you rise way down. So the height of the wave is from sea level up. Does that make sense? It's not the span. So one way we can say the amplitude is equal to the max minus the min divided by 2. It's like the average. It's the max minus the min divided by 2, okay? All right, if we know all that, then let's take a look at example 1. Let's make this easy, okay? All right, so first of all, it is periodic. So what I can do is I can just keep this thing going. I just didn't. I can keep this thing going. I just didn't, right? It keeps going on and on and on forever because it is a periodic function, okay? So it moves on forever, that same pattern. So let's do the period. So first the period is how wide is one curve. So you go ahead and highlight one curve. So if I just highlight one curve, we start at the top. There we go. There's one curve. You guys agree? That's just one up, down. I'm sorry, down, up. Same thing forever. So the period is how wide? Well, the width of this is 1, 2, 3, 4. Okay, so the period's 4. It's that easy. There's the 4 units, whatever the units are, okay? The amplitude is 2. Can you see that? Equals 2, because you go from the center of the curve and you go up 2 or down 2. Now you could do the max minus the min divided by 2. You could do that. I mean, you could still use a formula. Max is height of 2, subtract my min, which is a negative 2 over 2, but he's still going to get a 2, right? You don't really need to do the formula, but because it works, right? So you get 4 over 2, which is 2, okay? Now, f of 3. F of 3. Well, 3 is an x value. The answer is the y value. So the answer of these is the height, or the y value, which would be the height, okay? Well, f of 3 we can just count over, okay? You ready? I want everybody to watch. So we go over 1, 2, 3. I'm right here, right? That's 3. X is 3. What's the height? 0, right? Go over 1, 2, 3. There's the x is 3. What's the answer? 0. Okay. F of negative 2. All right, well, f of negative 2. F of negative 2, I'm going to go back. 1, 2, there's x, there's negative 2, right? What's the corresponding height? Negative 2. This is pretty easy, right? Thumbs up so far, you guys? You with me? Not too bad. But f of 99? Well, there's no way. I don't want to do this. I don't want to go 99 out. f of 99, let's see. Well, if this pattern repeats over and over and over and over again, right? Then every time I do a unit of 4, I'm right back where I started. Every time I do a unit of 4, I'm right back where I started. A unit of 4, I'm right back where I started. Does that make sense? As I go on and on and on and on and on. So let's see, what is 99 divided by 4? The reason I want to go to 99 divided by 4 is I want to find how many of these patterns does it have. Well, that's okay. It goes in 2 times, 8, 1, 19. 4 goes in 19. What is that? 4 and 19 is 4, 16, right? The remainder of 3. Okay, now the remainder of 3 is important because that's my answer. Let's see if I can describe this for you, okay? So for 20, I'm going to get 24 of these. I'm going to get 24 down ups, down ups, down ups, right? And at the 24th one, I'll be like right here in a sense, right? But way out there. And then I'm going to go 1, 2, 3 more, and I'll be right there. So the 99th, if I go all the way to 99th, the height has to be whatever the height of 3 is, which is 0. Okay. That's my answer. F of 99 is... Now, did I make sense? It's a little confusing. Want me to do it again? Want me to describe it again? I know the period. I know the pattern is every 4. So I want to know how many times does it do this if I go out to 99. So I knew the pattern was every 4. So I divided 4 to find out how many of those patterns do I have. I got 24 of those patterns, but then I got 3 left over. And the 3 left over is like, well, that means I'd have this end of the pattern. I'd go 1, 2, 3 more. And what's the height is the answer, is 3. Okay, turn the page. Okay. Okay, draw the following. So here's my graph, and it is periodic, so what I can do is put my little arrows on here because it keeps going. It keeps going. So this is periodic. We've done this before. So here's my parent function. And then, what do I want to do with it? Okay, Chloe, you know this, on the inside. So it's the opposite. Remember that? It's the opposite. So I'm going to take it to do the dance. I'm going to do the dance. I'm going to take this graph. I'm going to go to the left, 2, and up, 1. So I'm just going to take this graph and move it 2 back, up 1. So I'm going to take this entire graph, make it go back 2, up 1, so it's going to look like this. So I'll first, I'll just take this center point, I'll make it 2, 1, and I'll go ahead and put my pattern in here, right? Okay, how is that? Moved it back 2, up 1. And I think that's easiest if you see I moved that 1 point, okay? I moved the origin, okay? Okay, let's look at the next one. So the 3 means I'm going to change its amplitude. So the amplitude makes it 3 times as tall. 3 times as tall. So I'm going to take my original graph and I'll make it 3 times as tall. So that means at this point here, instead of being at 2, this point's going to be up at 6. This point, which is at -2, is going to be down at -6. So it's probably not going to fit very well, but I'll make it fit. So this one's going to go up to 1, 2, 3. And then 1, 2, 3, 4, 5, 6. And then it's going to go there, there. How's that? Three times as tall. So I made every one of my points here. Let me fold so you can see a little better. I'll fold here. Bring this down to it. There, that's easier to see. Compare them, right? So I just made this one go up to, instead of 2, I made it go up to 6. So it'd be a -2, I made it go down to -6, right? Okay, so it's just stretched it, a vertical stretch. Okay, give me a thumbs up when you're ready. I won't go until you're ready. Okay, now this last one, I'll bring this one down here so I can put them together, right? Fold it. A lot of kids get this one wrong, but not you guys, because, where's the equation? The 2x. A lot of kids get this wrong. It does not make it twice as wide. It does not. In fact, what happens is we need 2 curves. We need 2 curves in the space of 1. In the space of 1. So this is where we have a frequency of 2. So my frequency, I'm going to write that down. We have a frequency of 2. Anybody taking physics yet? Okay, you're going to do this in physics. You're going to talk a lot about frequency of curve lengths. So, if I want 2, what does that mean? Well, let's see. If I can just take a look at what one curve is. Let's see from start to bottom. I can start anywhere, but let's see if I start. If I start here, this original curve is going to look like this. And then it's going to come up to right there. And then it's going to repeat its pattern, right? Boom, boom, boom. And then it's going to go up again, right? So what we have then is we want to do inside here, we want 2 of these, okay? So to make it 2 of these, we're going to make it half as wide. To fit 2 in, we've got to make it half as wide. So if I make it half as wide, I'd be able to fit 2 into the space of 1. So here's how I'm going to do it. So I'm going to still start at 0, 0. So this point right here is at 2, 2, right? I'm going to bring it into here. This point's at 2, 2. This would be a width of 2. I'm going to make it a width of 1. Okay, this point is at 3, 2, right? So to make it half as wide, instead of 3, 2, I'm going to go 1.5. Okay, this point's at 5, right? So I'm going to bring it in half as wide. Instead of 5, I'm going to bring it into 4. So half of 5 is 2.5. 1, 2.5. Okay. And then I'm just going to continue this pattern. And it does make it half as wide. And so we'll get 1, 2 curves where we had 1 full curve, okay? How's that? All right. That's all I have. Homework then is drawing graphs, which that's all we